everybody. This webinar is going to be a little bit different. I think a lot of times, we talk about product-specific things, and sometimes you talk about more sort of abstract concepts as well, like network performance or network protocols like IPv6, for example. In some of our previous webinars, you can see all those on the Ubiquiti webinars playlist on our YouTube channel. But I wanted to cover something today that I see talked about a lot, and I didn't really see anything that kind of directly addressed these today. So basically, I see a lot of discussion on the community, on the forums, and in one-on-one discussions with a lot of WISPs over the years that I've personally had, where people are talking about different applications and different service offerings, and the differences between those and what they really demand from the network, and all those kinds of issues that you then end up having when you're talking about applications rather than just moving bits. So I thought it would be interesting to just cover some of the highlights of how these different applications operate for anyone who's unfamiliar, and really just hopefully give everyone a little bit of a kind of a basic set of knowledge for anyone who's not quite as up to date as some of the other guys on how these applications work and what they really demand from the network in terms of each user that's trying to use them. So without further ado, I will get started. This webinar should be a little bit shorter than some of the other ones. I wanted to keep it kind of a little bit more time limited than some of the sort of 90-minute ones that we've done in the past. And that way we can always follow up with another one next week on anything that you guys are particularly interested in, or I can pick one of the topics from my ever-expanding list. So without further ado, I will get started. Thank you all for joining me this morning, this afternoon, or this evening, depending on where you are in the world. And this webinar will also be put up on our YouTube channel, probably later today or tomorrow, in the airMAX webinars playlist as well. So definitely take a look at that if you haven't seen any of our previous webinars. We've got a lot of good ones on airMAX AC, airFiber, UNMS, UCRM, IPv6, network security, all kinds of stuff. So without further ado, I will get started with this one. Thanks for joining me. So when we talk about applications, what are we really talking about? And the way I like to think about it is, an application is really the reason that any of our users need a WISP, right? They're things like streaming video, Netflix and YouTube, we're all very familiar with, both from our own usage and from supporting our WISP customers as well. Web browsing and email, which, for anyone old enough, that's really what it used to be all about on the internet. And online gaming as well, which I know is often a challenge for a lot of WISPs to properly support as well. So I like to highlight applications specifically because I believe they're really what drive demand for the connectivity that we as WISPs provide. And I think that we can all agree when a new application such as Netflix or YouTube or a particularly popular online game like Fortnite, for example, takes off, we can all really benefit from that as WISPs, but that's as long as our networks are properly provisioned to handle them. I'm sure we've all seen cases, with some older network segments we have, for example, 900 megahertz networks where, the usage patterns seem to change overnight from basic web browsing and email, maybe the occasional Skype call to, distant relatives or something, to, trying to stream 3 HD streams on Netflix over the same connection. Things like that can happen. And, obviously there's a certain amount of preparation that we can do in our network designs to account for anything that comes up. But then there's some cases where, even very, very large networks, like all the cellular networks, if you guys remember back to, 2016, when Pokemon Go came out, I mean, that basically, crippled many of the cellular networks with their, billions upon billions of dollars of investment, purely because of the sheer amount of people using it. So, there's only a certain amount of prediction we can do about what the next, hot application is going to be. But I think the more we understand each class of application, which is what I'm going to try and give you guys a little bit of a taste for of today, for anyone who's not as familiar with it as some of the guys, that can really help us be prepared for whatever's going to come down the pipe. So I think by understanding each application better, we can improve, we can tune our networks better to perform better for our users, and ultimately we can give them more reasons to stay with our WISP as opposed to, moving to somebody else, which I think is really what we all want. It's much easier to retain a customer than it is to get a new one. So that's really what we want to help you guys to be able to do with our equipment, and hopefully with some things like this as well. So we've talked a little bit about applications there. I like to split applications from service offerings, and this is my personal definition, but I think it fits pretty well. I like to think of an application as typically something kind of like an OTT application, or over-the-top application like Netflix, or something that the user needs your internet connectivity to get to, but you're not really providing that application to them. You don't really monetize that application at all. You don't operate it. You don't really have any control over it. Whereas a service offering is something that you are basically offering as a separate product or revenue stream or subscription, or however you want to charge for it, to your customers. So things like if you provide them with in-home VoIP service, if you monitor remote properties with video surveillance, for example, if you have your own in-house IPTV service is a good example. And I think WISPs are actually in a really good position in many cases to create these kind of competitive service offerings, and it really lets us get into the same kind of bundled pricing and differentiation from our competitors that the cable guys and the DSL guys have been enjoying for a lot of years as well. With service offerings, WISPs can also move up in value. I always like to bring this out because any additional revenue stream that we can get from each customer is certainly worth having. And I think each one adds extra layers of stickiness to boost customer retention. Like we were talking about a minute ago, it's always cheaper to retain a customer than it is to get a new one. So I think things like IPTV, for example, in the past I've found to be very sticky, in that people really don't want to give up, a local TV service, for example, with local news channels that they can get through this kind of service that they can't typically get through, another OTT service, for example, or another WISP in the area. So that's how I like to distinguish between applications and service offerings. I think both are really important to understand for the modern WISP, especially as you're sort of building on a scalable foundation of things like airFiber and airMAX AC and UFiber, for example. We want to be able to provide you guys with the tools to have a flexible and scalable network foundation that lets you then look at these kind of additional revenue opportunities as well. So I wanted to go over something that I've noticed a little bit over the years in dealing with a lot of WISPs, in that I think there's typically 3 stages of WISP growth. And I say growth in the sense of, I suppose, growth in the types of service that they're offering, not necessarily in the scale of the WISP. For instance, you can have some small WISPs that are highly specialized and offer a large number of these kind of value-added service offerings, and you can have a very large WISP that really just offers, basic internet connectivity. It's not a judgment of whether one is good or bad. It's really a case of where you are with how comfortable you are with offering services to customers, what your customers actually need, how able to support them you are, all those kinds of things. But these are the kind of 3 stages that I've identified over the years, and I think they're pretty interesting. So the first stage that I see for any WISP, and really any ISP in general, is the data pipe stage, as I like to call it. So at this stage, the WISP is really focused on providing that basic internet connectivity. Basically, we're not really considering specific applications at this point. We're just moving bits, as we say. You talk to a lot of WISPs and startups and things, and basically the mindset that they have is we're moving bits from point A to point B. We don't care what they are. We're just shuttling them from point A to point B. As we build out the network, we get used to running it. We make sure we've got a stable revenue stream, and make sure the customers are happy. We can support the network. We can keep it growing, all that kind of stuff. The problem with this for the long term is that over time, competitors and application-specific issues tend to creep in for really any ISP. You might have, for instance, a lot of customers who are high-performance gaming clients, for example, and they're very particular about latency or jitter and things like that. Without a good understanding of what those different applications need, it can be a little bit difficult to really figure out how you can improve performance for them, or how you can help retain them. And also over time, as more competitors pop up, if everyone's offering this kind of stage of connectivity, this data pipe stage, if you will, then it becomes a little bit harder to differentiate from them. So typically, a lot of WISPs will start to move out of this data pipe stage after a little while. Again, depends completely on their own circumstances, depends on their customers, on their own familiarity level, all that stuff I just covered. But they'll often move into what I call the application delivery stage. So at this stage, issues with specific applications, or just one troublesome user who we just can't figure out quite what's wrong, and we begin digging into what they're doing on the network to figure out, oh, okay, they're streaming video at the same time as they're playing, Call of Duty online. That has this effect, that has that effect. Which route is their data taking when it gets out onto the internet? Can we affect that in any way? Can we set up a different BGP peering relationship to take a better route? All these kinds of stuff start to come up. And this tends to be driven by a combination of competition and those application-specific issues that I mentioned earlier. What I see is when a lot of WISPs and other ISPs get to this point, they sort of don't tend to describe themselves as moving bits. They tend to think of themselves as delivering applications, and that's in this case, these are still applications that the user is navigating to themselves. These aren't the the in-house provided applications typically that I discussed earlier as service offerings. These are things like Steam, PSN, Xbox Live, Netflix, YouTube, things like that. These over-the-top applications that users are using the internet connectivity that we provide to really access. So this leads us to have a little bit more what I like to call application-specific understanding, and we don't need to compile the source code for each one of these applications and go through it line by line. We just need to have a decent understanding from a network engineering perspective of the requirements of each one of these individual applications on the network, so that if we get a complaint, we can say, is this valid for us to address? What do we need to do? All those kinds of things, right? And I think at this point, the WISP is much better equipped to actually address real customer needs, because at the end of the day, the customer thinks in terms of applications, right? They think, I want Netflix to work, I want my Xbox to work. They don't really think, well, I am receiving 50 megabits per second best case with 15 milliseconds latency to the AP. They don't really care about that. They want their applications to work. So at this stage, the WISP is much better equipped to talk to the customer and really understand what the problem is, and better identify real customer problems and do that kind of application-specific troubleshooting where you see a problem enough times and you think, okay, this is actually due to DNS gateway issue. We're not resolving the name fast enough. You begin to pick up things like that over time. The third stage that I see a lot of WISPs moving into and talking about these days is what I like to call the service offering stage. So this is a stage where many WISPs will look to begin offering applications themselves. Not all WISPs look to go here. Some are content, and it's not a judgment on whether one is good or bad. It just depends which stage as a WISP you are happy with. Some WISPs don't want to have the hassle of offering in-house applications, for example, as service offerings, and that's completely valid. But a lot of them are talking about doing that and have been for a couple of years now. So I like to delve into them here a little bit. So service offerings, I think, are really interesting for the WISP. And again, with a network built on a scalable foundation with things like airMAX AC, airFiber, UFiber, airMAX, and all the other great tools that we have, really lets you get to the bottom of providing the foundation that you need to be able to then provide these service offerings on top of that. So one of the difficulties with providing these kind of service offerings, in-house applications like IPTV or VoIP service, for example, are they definitely demand the most understanding of the network and of customer needs. But the benefit is, of course, that they can provide substantial additional revenue per user to the WISP to raise that average revenue per user, or ARPU, figure. Again, it lets you offer those kind of similar packages to cable and DSL. Buy 25 megabit service from Comcast and you get these TV channels, for example. All of those things become possible to do as well, and you can also then offer kind of bundled pricing and use some of the techniques that other service providers do as well in that regard to make the the overall price of the service quite appealing. These kind of services can be very powerful when we're talking about customer retention, like I mentioned earlier. IPTV especially as we're talking about a lot of people switching away from traditional cable providers and things like that. There's a pretty good market that I've seen for WISPs and other local ISPs to offer, things like local TV channels, local news channels, things like that that may not be available, through the big streaming platforms at this time. So that's a pretty good consideration, and also things like managed in-home Wi-Fi are also pretty good as well. A lot of people still have difficulties with things like setting up their in-home Wi-Fi properly, making sure their clients are connected, distinguishing between a problem where they just haven't put the password in and an upstream internet connection problem, for example. So managed Wi-Fi is a pretty good example of this kind of thing. Maybe a good starting point for any WISP who's looking to move into this kind of service offering model. So I'll take a quick whiz through some of the applications that we all see and give a little bit of a basic view on some of the requirements that they have for the network. So VoIP, voice over IP, I'm sure we've all dealt with this to some extent already. Examples used today: Skype, classic; Discord, often for the gaming community and some of the younger crowd at the moment; and FaceTime audio on Apple devices. These are all basically just using IP packet-based telephony instead of the traditional circuit switched or mobile networks to do voice calls, right? And some of them are going to be using the same low bitrate codec that the mobile networks still tend to use, and some of them are going to be using very high quality, HD voice codecs as well. So the main thing to bear in mind with voice is that this application is most severely impacted by jitter and latency. Latency is pretty self-explanatory, right? For any of us who've set up a network before, essentially what this is the delay between a piece of data reaching from point A to point B. Jitter is related and similar, but a little bit different. Essentially, it is the delay variation as measured over a period of time. So if we have a 5-minute window, for example, we're measuring jitter over, and our latency is shifting over that time from 5 milliseconds to 50 milliseconds, we have quite a large amount of jitter. Ideally, we want that delay to be as consistent as possible, and that really helps these kind of real-time applications like VoIP sound a lot more consistent and usable, because otherwise, if you've ever been using something like Skype, for example, on a mobile phone, and you go through a little bit of a bad signal area, or there's a very brief interruption, or there's some good congestion or whatever, you'll notice that kind of fast talking effect where things seem to pause for about 2 seconds, and then the person's talking like they're, reading out the disclaimer on a radio ad. They go like that. That is typically caused by jitter. We are waiting for all these packets to come in, none of them come in, and then we get a bunch all at once, and we kind of jam them into the voice codec at the same time, and it attempts to basically piece the conversation back together. These applications can often be irritating to use with greater than 100 milliseconds delay from end to end. This is not always possible, but typically the maximum that I've seen these be really usable is something like 250 milliseconds. That can be pushing it, and you can start to have people talking over each other at that point. So although these are most impacted by jitter and latency, packet loss does also affect the MOS, or mean opinion score, as I've got here. The mean opinion score is a method of attempting to measure the quality of a voice call. And there's various ways to do that, which I won't go into here, but essentially if you see that term, that's what that means. VoIP is typically going to use a series of small packets which are sent at a very consistent rate, because we're dealing with real-time voice transmission. There will be occasional lulls and things like that in the conversation, one end going quiet while they listen to the other, for example. But the majority of the time we can rely on these being very consistent and repeatedly sent over a period of time. Typically, your average VoIP call is going to use less than 100 kilobits per second. Some of these other applications are going to use more than that, but you're not going to typically be looking at several megabits per second or anything like that, because audio itself is typically quite low bit rate compared to video. So we talked about having the network foundation to really make any of these applications work, and that is one of the big reasons why we spent a lot of time over the past couple of years working on the scheduler in airMAX AC. If you're talking about deploying VoIP applications, which I think pretty much anyone, if you're talking about supporting VoIP applications, which pretty much anyone providing service these days will be doing, I would definitely recommend using a sort of a radio access network of airMAX AC in either new, flexible, or fixed frame mode. And I'll go into the kind of latency difference in a little bit shortly between those two, but either one of those is very capable of supporting a large number of clients that are all using VoIP and other real-time applications, as well as non-real-time applications at the same time. airFiber is also a really good backhaul choice for supporting these applications, just because it provides that mixture of high capacity and very low latency, and very consistent jitter as well. So video conferencing is pretty similar in a lot of ways to these kind of VoIP applications. They do have a VoIP component, and again, these are applications like Skype video, GoToMeeting, and FaceTime. Using the front and back cameras on your iPhone or your iPad or your Mac. Essentially, these are also real-time applications, but we've added video into the mix, right? Which adds a few more complications. So, not only are the average throughput requirements for a video conference much higher than a VoIP conference, essentially, we also add a little bit more variation into this. So typically, whilst we could rely on something like 100 kilobits per second average with a VoIP call, depending on the video resolution, we could be looking at something up to 5 megabits per second used in the case of video conferencing, and that can be up and down at the same time. Bear in mind also that that is an average, so there may be places in the video where you are transmitting less than that, and places where you're certainly transmitting more than that at a peak, depending on the amount of motion in the video frame. And essentially what that means is, the network needs to be capable of providing consistent service to your clients, depending on what point they're at in the video stream. Obviously, we don't want, a radio that is having a peak due to a lot of movement in the frame, for example, to completely overpower everyone else on the AP. Which is exactly what we prevent in airMAX AC with the new flex and fixed frame modes as well. So definitely use those if you are looking to support video conferencing applications from your users. Again, packet loss does have some impact, much like VoIP, but jitter and latency are going to have the biggest impact on overall performance here as compared to packet loss, because in a real-time application, we're not going to do what TCP does, which is, cut our transmit rate down to the bone and then spend, an inordinate amount of time building it back up like we would in a bulk file transfer in web browsing, for example. We're pretty much just going to say, okay, that packet's gone. We're never going to get it back. Let's keep going. So you might get the occasional blip, but the occasional blip is much more preferable in terms of the user experience compared to very irritating jitter and latency issues. So moving on, I know this is a very popular one amongst a lot of guys in the WISP community today, because unfortunately a lot of the members of the gaming community tend to be savvy enough to measure the latency and ping and things in the network, but perhaps not as familiar with the architecture of the overall internet or the applications to really see whether or not that's an issue. So some of these are going to be very familiar to you guys, especially who get the angry calls from people at 10 o'clock at night. But essentially, a lot of the games that we're supporting on our networks today, Fortnite, Call of Duty, Battlefield, things like that, all different games, all different player bases, but one thing they do have in common is they're all highly latency and jitter sensitive. Again, these are probably most similar to VoIP, I would say, when the user is actually playing the game. Now, downloading the patches is a different matter, and I'll get to that shortly, but when they're actually playing the game, the network needs to treat it almost the same as VoIP, in the sense that this is a real-time application. We're typically sending fairly small packets, but very regularly. All these games rely on a very consistent timing to properly preserve the player position and any actions they take, like firing or running or jumping, whatever. And scaling that up to large games, something like hundreds of people in the same match, for example, is difficult when you have a mixture of latency and jitter going on amongst all the different clients. Packet loss, again, is definitely a factor, but not as much as that issues that you will experience with high latency and jitter. Now, I know that a lot of you guys have reached out and said, hey, what's happening with latency? Because I have customers saying, I ping the server and I'm getting, 15 milliseconds and my friend's getting 10 and this is causing me to lose. And I mean, quite frankly, a difference of that scale is not going to impact the, real discernible performance of the game or of any other players in the game. Now, if you're getting up towards 150 milliseconds, 100 milliseconds, 150, depending on the game, you can start to see a difference. And again, the old rule of thumb used to be, 200 milliseconds was kind of out of range of making a usable game. It can be difficult to really communicate that, I find, with a lot of customers, but the fact is that also in the back ends of these games, a lot of people are basically normalized to something like a 50 or 100 or 150 millisecond delay because they are coming from all over the world or all over the country. And if just one person had 5 milliseconds latency, we obviously can't have him having an unfair advantage over everyone else on the server. So bear that in mind when you look at the two different modes that I'm going to suggest here. So I talk about airMAX AC a lot in this presentation because we have spent so much time basically optimizing the system for no contention, or issue-free contention, I would say, latency and consistent jitter, and that is true for both new flex and fixed frame modes. I would say that a lot of you guys have also got in touch and said, hey, what's happening with the latency on fixed frame mode? If I set this in legacy mode or new flexible mode, I'm getting 5-10 milliseconds higher latency to the AP than I am with the flexible mode. And to be honest, that is not going to be a perceptible difference to the user in terms of their actual experience playing the game or really in any of these real-time applications. And in the case where you need to use fixed frame, that very small latency increase is absolutely preferable to any kind of contention or packet loss that may occur if you're having self-interference issues. So just bear that in mind. Moving on, web browsing. So this used to be the main application. I know that a lot of people set up our networks for, but it's kind of not fallen by the wayside, but it's definitely secondary these days to, does Netflix work? Do these things work? Because we've almost taken proper web browsing working for granted on our networks, but web browsing has a few tricks up its sleeve as well, because we're also moving to a lot of web-based applications like these SaaS, software as a service platforms, and these tend to be more sorry, I've got a typo there. That should be more packet loss sensitive than other applications that are real time. These are typically non-real time or kind of soft real time applications, and typically the biggest impediments to a good user experience are poorly performing DNS. If we're getting a lot of domains, for instance, if you go to the average web page, it's pulling resources from more domains than you can count. If you look at the developer console on your browser, it's not uncommon to see pages grabbing from 10, 20, 30, 40 different domains, and those all typically need a DNS lookup. So DNS can be a significant component of delay, and you may want to consider running a DNS server, at least for some initial name resolution inside your network. Packet loss is not a huge issue, I would say, but it is definitely going to cause a session to slow down if you encounter it at the start of a web page loading, for example. So again, things like airMAX AC in new flexible mode or fixed frame are going to be preferred. The choice between those is really going to depend on whether you're likely to suffer from self-interference or not. So moving on, streaming video. I'm sure we have all dealt with this one quite a lot in recent memory. Netflix, YouTube, Hulu, Amazon, a lot of household names that people are switching from cable providers to, or adding them on in addition to existing video services or cable providers. These are huge bandwidth users, as I'm sure you've all seen, and ultimately they're not very sensitive to delay unless you are watching something like a very high performance live stream, but even then those are typically delayed by at least 20 or 30 seconds anyway. So things like jitter and latency are not going to be as big of an issue for streaming video, but just overall network capacity and sporadic packet loss are going to be an issue because these applications typically still run over TCP. And if we lose a packet in the middle of transmitting a lot of video data, we're going to be limiting the throughput that we're able to get until our TCP session recovers. It's important to note that video eats bandwidth in these kind of sporadic peaks. A lot of the video content you watch is buffered ahead of time. If you actually look at your YouTube videos loading, for example, it's not like it drags the whole video down over the connection, because a lot of these guys say, well, a lot of people watch a video for the first 10 seconds and then click away. Why should we send the whole video down if we only need to send 15 seconds? And then if the user watches 10 seconds, we can download, the next minute, and keep it going that way. It makes more efficient use of their infrastructure as well. We've often got multiple screens in-house per use. Multiple screens per house in use. Mixed up my words there. And your average 1080p video stream today is typically going to run at an average of about 5 megabits per second. And with today's codecs, your average 4K video stream is likely to run at about 25 megabits per second, bearing in mind that those are averages, and peaks can exceed that, and peaks can also correlate together, leading to a shortage of capacity if your network isn't provisioned enough. So again, airMAX AC with the new flexible mode or the fixed frame mode are very, very capable at handling streaming video. We don't let any one particular client who's in a poor signal area or who has a peak content to send overpower other users on the same AP. And just one thing to bear in mind when you're setting your fixed frame allocation, 75-25, for example, downlink and uplink allocation, just bear in mind that you will need to make sure you have adequate uplink bandwidth for your clients. Otherwise, when people in the same house are using things that require upload connectivity, you can see streaming video performance start to suffer, because TCP ACKs going back from the client to the video server can often get lost or delayed. So just bear that in mind. Having more downlink throughput allocation does not always speed things up. Moving on to the next one. This one I'm going to go through pretty quickly. Streaming audio is basically taking the bandwidth requirements of VoIP and removing the real-time element, which makes it today pretty easy to support. We've got low throughput needs, typically under 320 kilobits per second, even for a fairly high bit rate streaming service, and we're not sensitive to delay with this application, very much like streaming video. So again, something like airMAX AC and NewFlex or fixed frame mode is able to handle this pretty simply. Bulk file downloads, I think, are an interesting case today, because I think there was a period of time when these were kind of considered to be a solved problem for a lot of WISPs. A lot of bulk file downloads were, say, a gig or two, and streaming video is really the network killer, if you will. And streaming video is certainly still a big issue for a lot of networks that aren't fully provisioned to handle all of the uses that they're experiencing. But bulk downloads have also had a little bit of a resurgence with a couple of things that I like to point out. So modern video games, for example, are demanding huge patches. I mean, even if you go out and buy the disc, as I'm sure you see on your network usage graphs, a lot of you guys out there, even if you go out and buy the physical disc, it's not uncommon at all to have a release day patch for a game that is 20, 30, 40, 50 gigabytes. And that's gigabytes, not gigabits. So it can be quite a drain on the network. The same applies to OS updates, like iOS for the iPad and the iPhone, and Windows 10, things like that. Some of those will also utilize peer-to-peer sharing of those OS updates as well. For instance, some variants of Windows will do that, which can also lead to a strain on the uplink of your client's connections to your AP as well. So these are interesting to consider because they can often choke your APs at unexpected times. A lot of these updates, for instance, like iOS device backups, for example, tend to self-schedule to occur overnight. And that seems great until you have users who are all doing it at once. You have another issue going on at the same time. You have a network maintenance window, for example, over that same period. You know, you plug a new AP in, and it starts getting completely put underwater by, you know, iOS 12 update traffic, for example. Some of these very large downloads are user initiated, such as game patches, you know, Steam updates, game downloads, all that kind of stuff. But you can usually see after the fact what happened. You know, was there a big you know, launch new Fortnite update, whatever, on that that day of the week. They can be a little bit difficult to predict, though, but just bear that in mind when you're seeing these kind of high throughput network usage peaks. Again, these use TCP, so they're pretty insensitive to packet loss to a point. Obviously, that will slow down the bulk download. The good thing is they're not real-time applications. You can pretty much just you know, let them run. When they finish, they finish. As long as they're not completely crippled, you know, users will typically be happy with the download speed. But at least they are not reliant on that sort of low latency and jitter like a lot of these real-time applications. Again, things like NewFlex and fixed frame mode on airMAX AC are great for these things because, again, we don't let specific clients overpower any other clients on the same AP. So everyone who's connected, you know, regardless of what they're doing, is intended to get a fair shake of the bandwidth that they're purchasing from you. You know, you can't just have one guy who's downloading, you know, a giant game on Steam on his PC, crushing everyone else on the same AP. So that's good. I will get through these pretty quickly, and then we can see if we have any questions. Basically, I wanted to go through a few of the service offerings here. So internet connectivity, like we talked about, is the basic service offering, you know, that any ISP, any WISP is going to offer. This is our basic, you know, internet connectivity. We're moving bits from the client's house to the internet, essentially, and back. You know, we're going to price that according to megabits per month, as all you guys are familiar with. And essentially, I consider this to be the ground floor of service offerings. You know, this is our foundation. And if you're looking to increase, you know, the kind of services and the ARPU and the retention that you can provide to your customers, then don't stop here. Start looking at some of the other things that we're going to talk about, like VoIP services, for example. You know, I know a lot of WISPs who have started running their own in-house kind of VoIP service, particularly if you've got, for instance, very rural customers or older generation customers who like having a landline, for example. This can be a pretty good application. Pretty much we're talking about the same you know, network performance considerations with this as we were for VoIP in the previous case of an OTT application like Skype. You know, we want to keep jitter and latency consistent, and we want to use airMAX AC in NewFlex or fixed frame modes for those same reasons. IPTV is a very interesting case. Again, there's a lot of WISPs that I've spoken to over the years who have looked at, and some who have very successfully deployed their own in-house IPTV service. This is going to be similar to streaming video, but essentially you're sending the content, you're licensing the content, you're providing the content to the user rather than an OTT service like Netflix or YouTube, which means you can benefit from it, which is nice. You know, a very good example of this is any local TV channels, local news, things like that aren't available on, you know, a Hulu or a Netflix, for example. I've also seen some WISPs distribute some of the channels that we'll be more familiar with, some of the more specialist stuff like the Discovery Channel, and really any other content that you are licensed to do. I won't spend a whole lot of time talking about licensing and IPTV network architecture today, but let me know if you guys are interested in that. Essentially what we need to do is typically we'll have a transcoding device which transcodes you know, data from an OTA or, you know, satellite video stream into IP. That device is inside the network, and then we distribute that throughout the network with multicast. And again, multicast, if you guys are more interested in that, I'm happy to go into that. Essentially, what we want to do with multicast is make sure that it is distributed only to the users who actually want it, not so much to prevent anyone who's not paying it from seeing the video stream, but just to prevent it from overwhelming the entire network. So we want to use things like IGMP or Internet Group Multicast Protocol, or Internet Group Management Protocol, sorry, IGMP snooping, things like that, which prevent devices who are not connected to clients who want to receive the multicast stream from receiving it, and this all just helps us have a much more scalable network. So I won't go too far into, multicast and IPTV network architecture today, but essentially just think of IPTV as requiring beyond the multicast requirement, very similar performance characteristics from your wireless network as things like streaming video did in the case of Netflix and YouTube. So video security is an interesting case. This is basically setting up, client radios that connect to security cameras and things like that, whether they're residential places, business locations, holiday homes that may be unoccupied for, 10 months out of the year, for example. And these can also be very interesting revenue streams that we can support with things like airMAX AC and airFiber, for example, because we're able to provide very consistent and scalable wireless connectivity to these cameras, and then we can provide recording even on site in something like a Unify NVR, for example, and we can charge the user for each additional stage of that. So definitely take a look at things like video security, especially in things like new building developments that don't have existing infrastructure, if you're interested in that as an additional revenue stream for your WISP as well. Wi-Fi hotspots are kind of similar. There's a lot of places like parks, outdoor areas, recreational spaces, unconnected buildings, for example, for both private and public clients, where they will pay to have Wi-Fi hotspot connectivity, and WISPs are ideally placed to provide that. I would typically recommend, because we're going to need those hotspot features like splash page, sign in, all those kinds of things, hotspot 2.0 functionality. I'd recommend using airMAX for this kind of radio access and backhaul network layer, and then using Unify for that access layer to connect directly to the Wi-Fi clients themselves. And you can use Unify to manage the Unify devices and UNMS to manage the airMAX side of things as well. Content caching, I'm getting to the end here, so thanks for bearing with me, guys. Content caching is an interesting case. And actually, before I get to content caching, I just wanted to touch briefly on the Wi-Fi use case again. I mentioned earlier, managed in-home Wi-Fi is a very good additional revenue stream and service offering for the WISP. We have a range of in-home Wi-Fi APs called the AirCube. Essentially, what these allow you to do is manage the whole network end-to-end from the back-end core of the network right into the user's home, all through UNMS. And essentially, you can do things like make sure that all of the Wi-Fi APs in the town that you're serving with your WISP are using in-home channels that are away from the channels you need to use for your airMAX network, so you can lower your noise floor. You're able to see what devices are connected, what signal levels they have, all that kind of stuff that really makes it very easy for you to offer a managed in-home Wi-Fi service. So definitely take a look at those. Just to finish off content caching, so this is an interesting service because it's kind of symbiotic in a way. This is really to benefit both you and your users. Essentially, the concept is that you would be able to store copies of popular content, for instance, like a local Netflix server in your network, and you would be able to avoid the use of any backhaul links that you have when a customer tries to fetch that particular content. So it's an interesting use case because it can potentially save you money and backhaul network capacity, and provide a perception of faster video streaming to your users as well. So it's kind of two sides of the same coin there. It may be a little bit difficult to obtain content caching servers unless you're a very large WISP or ISP or you're willing to host a server locally and pay to do so. But definitely keep this in mind as streaming video continues to grow in popularity, and as more screens per household come up, and as the average resolution continues to increase. I mean, you can even buy phones with 4K screens today, for example, and television sales are also on the rise at that resolution as well. So over the next couple of years, something to consider in the WISP network. So I think this is my last slide. Thanks for bearing with me, guys. But I wanted to touch on when's the right time to really look at any of these new services. And the thing is, there's not really a specific time. I can say, well, you've been in business for 2 years. It's time to do this. It all depends on what your goals are as a business, what you want to be doing as a WISP, what you want to be doing with your time as a WISP, and making sure that you can really run and support any services that you add. It's easy to get overexcited about things like this and say, hey, I want to set up all these services and get all this additional revenue with the network that I've already got built on this very strong airMAX and airFiber and UFiber foundation, for example. But what I would recommend is just make sure the network is solid first. Reliable service runs on a reliable network. Consider what your customers actually need. Do they actually want, IPTV, for example? Do they want managed Wi-Fi service? Do they want security? Maybe you can ask or, canvass some people in the local area, or, send them a little questionnaire with their bill, something like that. And really just make sure that any service that you put in, you understand it well enough to run it and support it going forward. So that's really what I had today. Thanks for listening, guys. Essentially, just as a quick summary, applications are what people need the connectivity that we as WISPs provide for. These are typically over-the-top applications like Netflix, YouTube, Xbox Live, things like that. But we can also look at service offerings, which are applications that we as the WISP provide to our users as well. And these can help improve our average revenue per user and customer retention over just providing basic connectivity. One point I just want to mention once more is airMAX AC and airFiber and all the other Ubiquiti operator products are really designed to provide the best tools for the job to give you this scalable network foundation, and then let you take your network, absolutely as far as you want to take it. So thanks very much, everyone, for listening. Open to any questions that you guys have. I'll hang around for a couple of minutes here. I see we've got a few in the Q&A box, so I will get to those shortly after the webinar finishes. But if you guys have anything you want me to answer whilst I'm still on the air, as it were, please do put it in the Zoom webinar chat. I'll just give it a couple of minutes here, and then I will leave you all alone. So thanks for coming today. I will send out a notice in the Ubiquiti ISP Professionals Facebook group in the next few days to set up the next webinar. Please do get in touch if you have any specific topics that you want me to cover. Otherwise, I will go with the next one on my list, and probably a bit more product-specific one next time, because I know those are always popular. And if you haven't already, please take a look at our Ubiquiti YouTube page. There is a whole big fat playlist of the airMAX webinars we've done to date, and definitely take a look at that and catch up on any ones that you've missed. Okay, I will call it a day at this point, and thanks for coming, everybody, and look forward to seeing you again on the next webinar. Thanks very much.